Good morning, good afternoon, not sure when you're hearing this, but this is your warm-up on linear function and intercepts. Remember, we're going to have a test after today on this concept. So I'm going over this video or this sheet with you through a video so you understand the answers. So the first ones, you've already had time to work on this. It says, which of the following equations are not linear? Explain why. Make sure you can tell me why or why not. Now the first one is linear, so you should not have picked that. This is linear, in case you don't realize. It has exponents of 1. You didn't have to write that, but I'm explaining it anyway. The second one, you should have non-linear. The reason you should have non-linear is because it has an exponent of 2. Anything that has higher exponents than 1 is non-linear. The third one, you should have non-linear. The reason you should have non-linear is this y. Variables cannot be in the denominator. Variables cannot be in denominators for these to be linear. The last one is linear. The reason it's linear, again, is because there is exponent of 1. Make sure you know how to tell if equations are linear or not linear and how to explain it properly. Now, when I'm talking about exponents of 1, I'm talking about, I'm going to add a word here, just so you know, that's the variables have an exponent of 1. Or the variables have an exponent of 2. Okay? It's not just a number with an exponent of 2 or higher. For example, if it said this, y equals 2 to the third power plus x, this would be linear. It would be linear because the variable exponents are 1 versus just a number having an exponent higher than 1. So hopefully you can see the difference. Now we go down to the second question. Let me move this for a second. Okay, the next question says, an elevator at Chimney Rock, North Carolina travels to its destination. The function, right here, this is an equation. An equation is a function. It represents the distance left to travel. So I give you an equation. I've given you a table. And I've given you a graph. Now, something I want to point out to you on this graph is, do you see any points? Do you see any points like this? I don't. So I could assume this right here is 0 to 55. I don't assume that. I know that because the table goes with the graph. And I know that this is 30, 0 over here. Are you allowed to guesstimate what this is? No, because I don't have anything in my table that tells me 17, comma something. So make sure you realize, unless you have accurate data, you can't guesstimate where certain points are unless you see them. So I'm going to make this larger now. Oh, I don't know if I can make this any better. Let's try 150. No, I think that is still too big, but let's go here. Okay, question number 2 says how. When it says how, you're not telling me what it is. You're telling me how. How can you tell what the x-intercept is from a table? How from a table? So you should have said something to the effect, the x-intercept in the table is the value where y equals 0. In a table, you are looking for where y equals 0. So the x-intercept in this example is 30, 0. It's not asking you to give the intercept. It says, how can you tell what an x-intercept is from a table? The next question, I'm going to drop it down. says, how can you tell what the y-intercept is from the graph? Well, we learned how to tell where y-intercept is. So you would say something to the effect of the y-intercept is the point where the line, make sure you're telling me how, not what it is. The y-intercept is the point where the line crosses the y-axis. And then if I asked you what it was, you would tell me 0, 2, 5, 5. Make sure you know what the question is asking. Question number 4 says, interpret. Interpret means write a sentence. What is 30, 0? Make sure you're telling me what both of those mean. Does yours say 30, 0? Maybe yours says 20, 85. Let me pause and check. No, yours says what mine says. Interpret. Interpret the point 30, 0 in a sentence. 30 represents the x-axis. The x-axis is time. So this would be after 30 seconds. This is about an elevator. So this would be the elevator has reached its destination. I don't want to say is at 0 feet from the ground because that sounds weird. 0 feet from the ground means it has reached its destination. And the last question here says, what is the distance from the destination after 8 seconds? So I want to go back up to the graph here, and I want to ask you a question. So 8 seconds, I'm going to grab blue here. 8 seconds is right here. If I go up to 8 seconds, it looks like it's here. Do you know this point? No. So if you guessed that point, you can't guess it. You have a table, and there's nothing in the table, but you have this graph here, or I'm sorry, this equation here. So that's what you should have used to figure this out. The equation lets you know what 8 seconds would be exactly. So you can either use your graphing calculator or you can use the equation and you would substitute 8 in for x. 17 over 2 times 8 plus 255. That's how you would find 8 seconds. 8 seconds is 187. So it says, what is the distance from the destination? You would say 187 feet. What's my point here? Make sure you take your time. Make sure you read them. Make sure you don't guesstimate if you can't find an answer exactly. Use the information they give you to answer the question.